All right, for today's video, we're going to go over the example I gave you guys. It says John is putting together a video for college scouts. He records himself taking 100 shots and is going to put together a video of all of his makes. During his 100 shots, he only makes 41 of them. Oof. He decides to wait to edit it all together, but forgets because he's playing NBA 2K day and night. He sends the video out to the recruiters, and when he realizes what he's done, they tell him that they will watch, at random, 20 of the shots from the video. If they see that he makes 10 or more of them, he will get the scholarship. What is the probability that John gets his scholarship? So this can be a pretty complicated one if we don't actually break everything down. So let's go ahead and try to break everything down first. First, we need to figure out what all of our variables are. So let's list all of our variables. We're going to need P, the probability of success, Q, the probability of failure, N, the number of trials, X, the proposed value that we're looking for, R, and then we're going to use these four to find our mu and our standard deviation because those are going to come in handy. Well, as we said, probability of success is what is the probability that he makes a shot on any given video. Well, in the video, he only makes 41 of them of 100, which means that if we take the number of his actual makes and divide it by the number of his actual attempts, we should get his p-value. So let's do that right now. 41 divided by 100 gets us 0.41. This is going to be the probability of his success. Let's fill it in. All right, next up, let's find his probability of failure. Well, we know that we can find the probability of failure by taking the number 1 and subtracting from it his probability of success. So let's do that on a calculator real fast. 1 minus 0.41 gives us 0.59. This will be his probability of failure. All right, next up, we need to find the number of trials. Now, this is actually given inside of here, so let's read it very carefully. So he takes 100 shots, and you might think, oh, 100 shots, that's the number of trials. When in fact, the number of trials is going to be 20. We know this because the scouting department is only going to watch 20 of the shots that he takes. So we're going to go ahead and use the number 20 as our number of trials. Finally, we get to x. X is the proposed number we're looking for. Well, if we read very carefully on here, you will find that the proposed number we're looking for is 10. Now, this is going to change, as we mentioned before, since our x values always have to be either a 0.5, have a 0.5 at the end of them. So we're going to go ahead and put it as 10 for now, and we'll just change it once we get to that point. Now we need to determine, is our 10 going to be a 9.5 by subtracting 0.5, or is it going to be a 10.5 by adding 0.5? Well, if we actually go back to our notes, we can find the answer to that really quickly. So as mentioned before, it says an easy way to think about it is that when we are traveling to the right or shading our curve to the right, we will be subtracting 0.5 from our x value. When we are traveling to the left or shading to the left, we will be adding 0.5. Now, in order to determine if we are going to subtract 0.5 or add 0.5, we first need to figure out what direction it is traveling on our curve. Remember, it's traveling to the right if it is greater than, and it is traveling to the left if it is less than. Let's read this sentence really carefully. They tell him they will watch at random 20 of the shots from the video. If they see that he makes 10 or more of them, he will get the scholarship. We know that or more means greater than, and greater than means we're traveling to the right, and if we are traveling to the right, we need to subtract 0.5. So let's go back to our list. And we know that if we subtract 0.5, we get 9.5. So our x value is going to be 9.5. From here, we need to find our average. Average is what you get when you take your number of trials and you multiply them by your p-value. In other words, n times p. So let's multiply 20 times 0.41. When we do, we get 8.2. We'll use this as our average for now. Next, we need to find our standard deviation. We know we can get our standard deviation by finding the square root of n times p times q. Well, as mentioned before, n times p is 0.82. Let's multiply that by 0.59, which is our q, and that's going to give us n times p times q. Don't forget, you need to square root that value, and when we do, we get approximately 2.2. Let's write that down. This gives us all the variables we need to create a curve. Let's make a curve with the center being 8.2. As we travel to the right, we'll add 2.2, and as we travel to the left, we'll subtract 2.2. Now, I actually did this before I started this video, so I'm going to go ahead and just bring that up. We know that we have 8.2 as our average, and each standard deviation is going to be adding 2.2. I've done that to the right, and I've subtracted it to the left. These are the values. We also know that we're going to be shading to the right at 9.5. 9.5 is our x value, so let's go ahead and draw a line for 9.5. Figure 9.5 will be in between 8.2 and 10.4, so let's put it right around here. Let's also make it a little bit more bold so we can see it better. And let's go ahead and make it red so it really stands out. There's our line. We know that's going to be at 9.5, and we are shading to the right. Now we can use all of this to set up our equation for z-scores. Now z-scores, the equations will look something kind of similar to this. Now these are from other problems that I've done in the past, so I'm just going to change these. We know that we have to start with our x value. Our x value was actually 9.5. Our average, we said, would be 8.2. And our standard deviation is going to be 2.2. Let's go ahead and find out what that is. So 9.5 minus 8.2 is 1.3. So we can fill that in right here. 2.2 is still our standard deviation, so let's now divide by 2.2. This gives us approximately positive 0.59. We now have our z-score. So let's go ahead and look that up on our z-chart. If we look up positive 0.59 on our z-chart, we find that to be right here at about 0.7224. Let's write that down as well. And this is going to be the probability to the left. Now let's go back to our demonstration here, and we know we're not actually looking to the left, we're looking to the right. So this isn't actually the right score. We need to take this value of 0.7224 and subtract it from the number 1. One minus 0.7224 gives us approximately 0.2776. Now, what does this tell us? Well, this tells us that John's chances of getting a scholarship are not great. John actually has a 0.2776% or probability of doing it, which is approximately 27.76%. In other words, John has about a 1 in 4 chance of getting his scholarship. This will now conclude the video for today.